Okay everyone, let's go ahead and start off with chapter number 20, which is going to be our first chapter involving calculus. Now before we actually get into calculus, let's go ahead and start thinking about some of the principles behind calculus and introduce ourselves to some of the fundamental ideas of that particular topic in mathematics. So we're going to go ahead and start off again with an introduction, section 28.1 and 28.2. And it's based upon this idea of average rates of change. Now, let's go ahead and just take a look at a simple example here. And let's say, for example, that the Shinkansen leaves Tokyo at 12 noon. It arrives at Nagoya at 1 o'clock. And let's just say, for example, that's 200 kilometers away. So what I've done here is I've drawn a graph that hopefully will be able to show what this will be able to depict what this example is stating. So let's say, for example, that this is right at noon, at 12 noon, and we'll go ahead and talk about this as minutes. This is distance here. So once we leave at 12 noon from Tokyo, of course the distance is 0 from Tokyo, and then that's at 12 noon. And notice that when we actually get to Nagoya at 1 o'clock, that's 60 minutes later, and it's 200 miles away. Okay. So what we can do then is we can go ahead and draw, like at 30 minutes, it's going to be at 100 kilometers away. So I can go ahead and just draw a straight line that would then go ahead and depict this particular situation. So now what are we going to do then is we want to go ahead and talk about this whole thing about average rates of change. And in this particular, being that we're dealing with distance and time, we're dealing with speed. So let's go ahead and say that s of t is going to be the distance function. So in other words, this function is going to then go ahead and describe, as time moves forward, how far away the Shinkansen is from Tokyo. So average speed is always going to be, or average speed is going to be the change in the distance divided by the change in the time. Okay. So what I can do then is, for any particular two values of time, I can then go ahead and calculate the distance at that point and at the other point, and then go ahead and calculate what the average speed would be. Now, assuming that this graph is accurate for this particular example, we could go ahead and choose any particular values that we want along the time. So let's just say, for example, that t sub 1 is 0, t sub 2 is going to be equal to 60, and again these are in minutes. Then that means that if I do s of 0, this of course is the distance. When the time is equal to 0, that's 0. And s of 60, of course that time is going to be, that distance is going to be 200 kilometers. Okay, so what I can do now is, being that I have basically this coordinate here and this coordinate there, I can then now go ahead and calculate the average speed. So the average speed then, for this particular case, is going to be equal to s of t sub 2, which is going to be 200 minus 0, divided by, this is going to be 60 minus 0. So what I come out with is going to be 200 divided by 60. That's the same thing as 20 divided by 6. That's the same thing, if I reduce that by 2, that is going to be 10 over 3. And this is going to be kilometers per minute. Let me go ahead and write this way. So what that means then, is that means for every 3 minutes you travel 10 kilometers, and there you go, you're talking about an average speed for the Shinkansen. Now, could we have chosen another particular value for t sub 1 and t sub 2, found the distances at those two values, and found the average speed? Sure, we could have done it for any of the particular two coordinates that we chose based upon this graph here. Okay, so that's how you can actually go ahead and find the average speed. Now let's generalize a little bit more, and let's talk about average rates of change, because what we're talking about here is speed, and speed of course is a rate of change. So let's go ahead and erase this. what we want to do is we want to be able to say, in general, okay, if you're given any 2 points, right, let's just say an x sub 1 and a y sub 1, and another point which is x sub 2 and a y sub 2, if I go ahead and calculate the average rate of change and how quickly these things are changing, so the average rate of change is still going to be the change in the y values divided by the change in the x values. So what we can say then is that this is y sub 2 minus y sub 1, all divided by x sub 2 minus x sub 1. Now I'm hoping that all of you recognize this formula here. What is that? You guessed it. That's how you calculate the slope of a line. So what we know then is that this is another way of actually just calculating the slope. So that's why when we go back to this example here, when we talked about the average speed, being that we're dealing with a line, the slope of the line is going to be constant regardless of where you are on the line, and that's why we could have chosen any two particular coordinates of t and s of t to be able to calculate the exact same rate of change, or the average speed, which would have been 10/3 or 10 kilometers for every 3 minutes. Okay, so that's what you need to do in order to go ahead and start working with some ideas with calculus. Again, this is just an introduction, we're just getting started, but it's going to be important that you know that the average rate of change is always going to be the slope of 2 points, the slope of the line joining any 2 coordinates that you are given. Okay? All right, well, give it your best shot. We'll see how things go tomorrow. Okay, bye-bye. Now,